Hello, Remote Physics 1 students. Today I am going to be talking to you about Lab 9. Now, Lab 9 is a bit different than what the face-to-face students are doing, so please make sure that you follow the remote instructions. Those are the ones that I have open right here. I would also recommend reading through the introduction and familiarizing yourself with the equations because you're going to be using most of them, or at least derivations of most of them, for your calculations for this lab. So make sure that you understand where they're coming from. So in part 1, you're going to be determining the coefficient of static friction using a hardcover book and a coin. So what you're going to do is you're going to prop up the cover of the book and you're going to place the coin right at the edge of it. And then as soon as the coin starts to slide, you're going to measure that height. Okay? You're also going to want to measure the length or your width, as it says here, of your book cover. So you're going to want to get this distance here. And you can see in your first table, you're going to have the width of your book cover. We're still working on this, but it is going to be in meters, so record it in meters. So if we look over at the template, I have a hardcover book here, Quantitative Chemical Analysis, and I measured the width of the book, and it was 23.9 centimeters or 0.239 meters. And then I propped up the cover of my book as it shows here. Okay, and as soon as my coin started sliding, I measured that height. And the height that I got was 5.5 centimeters or 0.055. Okay? So you'll notice that I'm recording under partner 1 for the smooth cover. This book happens to have a really smooth cover, which is why I chose it. But now I'm going to get into the calculations. Okay, so we're going to go through how you calculate theta limit in degrees. So you'll notice up here that this represents a right triangle, right? Over here where you measure your height, right? This is where your right angle would be. So you have this angle theta here, and that's what we're trying to calculate. So opposite this angle, you have your height, and then over here, of course, the longest side is your hypotenuse, right? And so we know a relationship between the opposite side and the hypotenuse, and that's sine. So what we're going to do is we're going to use inverse sine and take the maximum height over the width of the book cover, and we're going to find that angle. So in Excel lingo, that would translate to equals degrees, open parenthesis, a sine, open parenthesis, and then we're going to do our fraction, right? So we're going to have height divided by width and close our parentheses. So we get an angle of 13.30. Now the last thing that we need to do for this table is we need to calculate mu s. So we can see from the directions in step 6, calculate the coefficient of static friction by using equation 5. So this is equation 5 right here. So we're going to use tangent, because we know that tangent is equal to sine over cosine, to calculate mu s. So in Excel, that would be equals tan radians and then your angle, so B5. Okay, so we find that mu s for our smooth surface would be 0.24. Now for part 2, I used the same book, and so I'm just going to port over this information that I already have. Okay, for the height, I lifted up my book to be 6.5. So over here, if you remember, it was barely sliding at 5.5, but when I lift it up to 6.5 centimeters, then it slides pretty easily. Okay, so that's going to be 0.065. And so now we have to calculate what this new angle is. And we expect, of course, that it's going to be a bit bigger than this one. Okay, so that's a good way to check your work. We're going to do it the same way that we did it in table 1. So it's just going to be equals degrees, a sine, and then we're going to take our height divided by our width, And so now we got that our angle is 15.78, and that's exactly what we expected, right? It's a little bit bigger than this one. So the next thing that I'm going to do is I am going to drop my quarter, well, not drop it, I'm going to hold it at the edge of the book and release it, and I'm going to time it 5 times and see how long it takes to reach the edge of the book. So now you can see I have my 5 times, and so I'm going to take the average of them, so equals average, and then I'm going to highlight those 5 times and hit enter. Now the next thing that I need to do is I need to calculate the acceleration. So if we look at the, we're on step 6, okay? So we're going to rearrange equation 2. So let's scroll up and take a look at equation 2. We're going to rearrange this equation and we're going to solve for the acceleration. So that means essentially what we have to do is we have to take our acceleration and get it by itself, right? So that means we're going to take our displacement or our width of the book, multiply it by 2, then divide it by t squared. So I'm going to do that right here. So we have 2 times the width of our book divided by the average time of our slide raised to the second power. All right, and that's our acceleration. Now the last step is we have to calculate mu k. So if we look back at our instructions, we can see that we are going to calculate it using equation 6. Okay, so let's take a look back up at equation 6. So mu k is equal to g sine of theta minus a over g cosine of theta. Okay, and all that we've done here is we've calculated the net force, right? And we are solving for mu k, right? So that's over here. So this is our whole equation telling us that our net force is equal to mg sine of theta minus mu k mg cosine of theta. And if you're not sure where that comes from, draw the diagram, and then it'll probably be really clear. But essentially, this is your force that's making the object go, and this is your frictional force that's opposing it. All right, so we have equals g, sorry, not g. We're going to put it in the numerical value, 9.8 times sine radians, then our angle. All right, and then we're going to subtract our acceleration. And then we're going to divide by 9.8 times cosine radians of our angle. Okay. Oh, and I missed a parenthesis. And then we're going to get mu k, and that is not right. So I'm going to go ahead and add some parentheses here so that it knows that all of this is part of my numerator. You shouldn't be getting a whole number value. There we go. That's better. All right. So our equation is open parentheses 9.8 sine radians b14 minus b16 divided by 9.8 cosine radians of b14. Just look at this equation. I realize I didn't say what all the parentheses were, but do it this way and it'll work out great. Now let's just say that my partners came back with all of their data, and so now I've finished my 2 tables. So now we're going to do a bar graph just like we did in lab 3. So I'm going to click out away from the rest of my data, and I'm going to select my bar graph option. Okay, of course under my insert tab, and then I'm going to do select data. Actually, before I do that even, I'm going to go over here and I'm just going to copy my mu-s. Okay. All right, so now let's go back to the design tab and click on select data and then click add, and then we're going to call this series mu-s, and we're going to highlight our 3 mu-s values. Sorry, my dog is barking in her sleep. All right, so now we're going to add a second series, and that's going to be mu k. So I'm just going to call this mu k. All right, and then I'm going to highlight my mu k values and click OK. And now I'm going to edit my horizontal category, and then I'm going to highlight smooth through glossy. And then click OK, and then I'm going to click OK again. Then I'm going to go grab myself a quick layout. So yeah, just do layout number 1. And we'll call this coefficient of friction. There we go. All right, and that's it. Now we've got our bar graph. So that's pretty much it for Lab 9. Let me know if you have any questions, but otherwise, best of luck on performing Lab 9 and doing all your calculations. I hope this helped.